Fine. Once again, morning or good evening from wherever you joined. Thanks for attending this demo. This is Satish from Isha. Just quick introduction about me. I have total of 13, 14 years of experience across various area of information technology, be it a performance testing, performance engineering, product development. So across life cycle, I've been working till now, and I've been part of Isha for taking trainings last 2 to 3 years, especially focusing on performance engineering, and then couple of testing tools, testing methodologies, DevOps, um, uh, end user experience, K6, so Selenium for performance. Those are all the other courses which I frequently take. Right. So this session or this batch is going to be for performance engineering, and today I'm wanted to focus on what is that we are going to learn over the next 3 to 4 weeks. Right. I wanted to give a quick recap on all the topics. What is that you're going to learn? Okay. And first, this performance engineering, the course content is planned in such a way that, or it has been tailored in such a way that it would fit the need of any performance tester, say, who say that, okay, I'm today doing scripting and execution. I'm just doing a basic monitoring. I just do the analysis of my LoadRunner or Jmeter report and give those to development team. And I wanted to scale further. Okay, or you might be totally new to performance itself. Even for you, without even, there are always going to be two paths, right? One who does the testing and who does the engineering. But currently, in the projects where we are observing, there are not going to be dedicated testers or dedicated engineers. They might not have that cushion to include two dedicated people. So wherein a single person has to do all these things, right? And more and more the teams are becoming lean, where multitasking is expected, right? Even teams are expecting a person to do both functional and performance together. So which means for performance and engineering, you might not get a separate resourcing at all. Okay, so that is where you may have to upskill yourself. That definitely there is a need for upskilling yourself to make yourself relevant, right? You have to be relevant in the current scenario where people expect people to do multiple things. We have been seeing is that where a tester has to do some level of development also, and then full stack QA engineers where a person has to do both functional and automation together. So which means definitely if you wanted to expand your skill set, if you want to become relevant, you have to definitely upskill yourself to a performance engineering area. And this course is very much tailored to a level where a performance tester or a person who is new to performance should be able to go to the next level of performance engineering. Okay, it's going to be a kind of a basic to intermediate level of course content tailored for the practical needs of the projects. Okay, so as I listed here, today you might be doing all these things, whatever I mentioned at the left. Maybe doing a scripting. You might be a very good person who does the scripting for complex scenarios, does the execution, provide the summary report, right? All these things include. But additionally, you should be also be able to, at the early in the life cycle, when a development is happening, right? When a development is happening, mostly we will not be getting involved. If you look into it, most of the time they will get involved only maybe last a month or last 2 months before it goes to production, right? So if you wanted to stay relevant, we wanted to engage early. We have to, if it's a 1 year project, right? For example, and the development will start from the second month or third month. So in that case, we wanted to be more relevant. We wanted to get involved even at least in the third or fourth month, where we can start doing some engineering work along with the developers. either from a server-side profiling or client-side profiling. Even when a particular API is developed, when a particular service is developed, we should be able to go and look into the way to optimize the response time to make sure that there is no memory leaks, right? All these things are going to be part of your performance engineering. So the objective of the course is to make sure that you will know server-side profiling, client-side profiling. You should be able to go and take a heap dump, thread dump, and then analyze it. You should be able to go and take and analyze the AWS reports. You should be comfortable in using these JProfiler, JVisual VM, JConsole kind of a tools. And then you should be able to benchmark your JVM, and you should be able to go and use these APM tools comfortably like AppDynamics or Dynatrace, right? And then you should be able to go and monitor your servers, your application, either using commercial tools or open source tools, right? All these things you should be comfortably doing it. When we say you wanted to learn performance engineering, you should be able to handle all these things to a certain level. Okay. So when we say performance engineering, it's going to be combination, right? It's going to be combination of a testing, which you might be already doing it, and of course the system analysis. System analysis will include whatever I mentioned already, right? All these things from server-side profiling or client-side profiling, taking the dump and analyzing it. All these things are going to be part of system analysis. It is always good to know a little bit of programming. We are not going to code anything, we're not going to develop anything, but we are going to talk to the developers. Okay, our end users are going to be developers whom we are going to share the analysis, whom we are going to share the reports, diagnostics, everything. So it is always good to talk. When we go and talk to them, it is good to talk to them in their own language. So little bit of programming will help, but it is not a mandatory. And then a little bit about networking and administration. You should be able to go and install the tools, install the softwares, right, on your own. We cannot expect somebody else to install you software tools. That the days are gone where we'll just raise a request and somebody comes here, install the tool, deploy the application for you, configure the database. No, all these things are not going to be done by other teams, as we going to be working in a very small pod-like structures. We have to do it by on our own. So you should be a little bit comfortable in doing it. Maybe day one, day two, you won't be able to do everything, but you should be able to start getting yourself comfortable in doing things on your own. Okay. So in this performance engineering course, yes, we are going to cover a lot about the system analysis, whatever I mentioned here. Plus, at the beginning, right, we'll also focus on a couple of important Java concepts, Java basics, and we'll also look into some of the basic programming as well, to just break that barrier, right? Will I be able to do the engineering? Will I be able to go and talk to the developers? Because most of the time, we go and tell that a response time is high, or my there are more errors, there are more failures. Developers always question back saying, no, I'm not seeing any problem. Your script might have a problem, your test data might have a problem, environment might have a problem, and they always push back, right? And we will struggle in convincing them. Now, when we are going to go and talk about the at the code level, when you're going to go and say your method is having a problem, slowness, or your class is having a problem, or your object is having a leak, right? Then you're going to have you face even more problem from them if you're not comfortable, if you are not confident. So the objective of having covering a few of these Java basics and Java programming is to make sure that you get that confident, right? Idea is not to go and become a developer. Idea is to just to get some of the very basics of Java programming. Our typical Java program is going to be developed. What are the class, how to create multiple class, how to call one class from another class, how to make a DB connection, how to make a HTTP connection, how to compile it, how to create a jar or a var, how to deploy it in a Tomcat. If you have done all these things and so on by yourself, you will not feel that you're in a totally a different world or different zone, right? You can feel confident, and when you go and talk to the developers, at least you'll speak with confidence, right? Of course, you're going to have challenges convincing them, but you should get started with some way. We cannot be sitting behind just sending the report and then debating with them. Okay, so that is the reason at the beginning we will, as part of the day 1, day 2 from tomorrow, we'll start looking into the Java basics, JVM basics, Java programming basics, a little bit of hands-on. Okay, I'll just go over the various topics which we are going to cover over the next 2 to 3 weeks. Sorry, 3 to 4 weeks. Okay, as I said initially, we'll start with the Java basics, the JVM basics. Let me go to the slides as well directly. Yeah, so we'll have a course, we'll have a session called Think Like a Developer for covering the Java basics, JVM basics, and also on the little bit of programming, whatever I told, creating a single class file, multiple class file, calling a DB, making connection to a HTTP call, and then calling one class file from another class file. All these things we will do it hands-on. Okay, using the Eclipse, you would need a Java to be installed. You need a Eclipse to be available in your laptop for you to do your hands-on after the classes are over. Okay, and then once we know these basics, then we will go one by one from a engineering perspective. We will start with the way we are going to do is you're going to get involved as a performance engineer in a project. What you're going to do from day 1, week 1, what are the activities you're going to do it, right? As part of the early performance engineering, an application is getting developed, you're not going to do a load testing or endurance testing or heap dump or thread dump initially, right? It is more about early performance. As a application is developed, as a single pages are getting developed, your APIs are getting developed, we'll go and do the early performance response time profiling. We call it as a server-side profiling, or your single user performance engineering. Okay, so we're going to use the tools like JProfilers, Chrome developer tools, access blocks for doing these early performance engineering, for both from a response time perspective, also from the memory perspective. Okay, see, there are two things which are going to have a performance impact. One is your CPU power, and second is your memory or heap, right? Always that is how most of the time your application is going to get into some problem or some kind of a capacity problem. Okay, so more the response time, more the memory consumption, more probably you're going to have, and your server is going to have a capacity problem. So at the initial level, at the beginning level itself, when an app is getting developed, if you can go and optimize these two things, if you can reduce the memory footprint, or if you can arrest the memory leak, or if you can go and reduce your method level response time, okay, whatever way it is possible, then your, say for the login, instead of taking 5 seconds or 8 seconds, if you can reduce it by 3 or 2 seconds, right? It's going to make a huge difference when you're going to do a load testing. Same way, if there's a memory leak for a login functionality, right? And if you're going to run a load test, endurance test, there it will get explode. There you will have a JVM crash. There you will have a lot of memory issue. And then finding out a problem and then fixing it, you might not have enough time, and your deployment to production will get impacted, right? So always, as a performance engineer, will get involved early, doing the response time analysis, memory leak analysis. So that is what we will get started with as well from a learning. Okay, we will use JProfiler kind of a tools to do the profiling. Okay, and then we'll go into in-depth onto memory, because memory is a huge area and there's a lot of things to learn. So get into deep into memory leak analysis, heap dump analysis, garbage collection analysis. So if you look into these specific segment, as I mentioned, for response time analysis, we will use Eclipse, we'll use Java, we'll use JProfiler, we'll use Tomcat, all these combination of tools to find out the response time issue, and then we'll go profile, and then we'll see how to provide the recommendation. Same way with memory leak as well, we will have a both theory and practical session on memory from a leak perspective, from a heap dump perspective, how to identify leaks, how to identify memory patterns, and then how to take heap dump, how to analyze the heap dumps, So we will use combination of multiple tools. It will be JProfiler, it will be Visual VM, it will be Eclipse memory analyzer tool, MAT, okay, and then the Eclipse as well, right? All these tools there's some chat. Not able to see the screen share. Oh, just one second. I'll share the screen again one more time. 1 minute. I'll stop it and share it again once again. Yeah, maybe accidentally I might have turned off. Okay, I think there's some network disturbance where it got, I think, stopped. And hopefully it is now visible. Yeah, so we will have very deep dive sessions on the memory basics of, again, we'll also go and understand the difference of, there are two areas in your JVM. One is your stack memory, one is your heap memory. So these basics as well, we'll try to understand what is stack, what is heap, and what are the common problem you might get with the stack, and what are the problems you might face with the heap. And then we'll go into the memory leaks, heap them analysis, all these using different tools. And we'll also have a deep dive into garbage collection as well. What are the various GC concepts? What are the various segment of GC in a JVM? What are the various collectors? Uh, what are the various process involved in garbage collection itself, like marking, deleting, compacting? So we'll go again. All these things are going to be completely practical. You might have 20% theoretical for me to explain you the concepts, and remaining is going to be practical, right? From there, once we complete the memory part of it, right, we'll go into the threads. Uh, Again, you need threads to execute a task, which in turn is going to use a CPU. So thread is another important component of the performance. Your like your response time, your CPU, your memory. Thread is another important component which is actually going to handle the task. So we'll go and understand what is Java thread, how the Java threads are created, destroyed, how it is configured, right? Practically, we'll go and see how these threads are created and destroyed during the whenever your server is going to execute it. And then we'll try to understand what are the common problems we might face, like the thread contentions, or the thread is having any, if the threads are going to go in a blocked state. We'll go in depth into these area as a next part, right? Um, we will again use Visual VM, a JProfiler, and then we'll also use the something called fastthread.io. So with a combination of all these tools, we'll try to learn what are the various thread contention, how to analyze those thread contentions. If the thread, the configuration of threads might be very less, how we will go and configure those threads, in what are the methodology to be used, and if there's a problem with the thread having going into a blocked state or monitor state, how to analyze those threads, how to take the thread dump, how to analyze those thread dump in depth. We will be looking into it. Okay, and from there we will go on to the other aspect, right? Most of the time we will look into the server side part, like CPU, like memory, like thread dump, garbage collection analysis, GC tuning, everything. But one more important thing is, from a end user perspective, client side engineering, client side profiling is equally important, because that is what your user is going to look into it, right? For a user, he will not worry, like you using your Amazon.com or Facebook.com, you will not worry whether the your memory is good, or your CPU is good, or your GC is good. All you want to know, you will be interested is whether my site is loading fast, whether I'm having a good experience while I'm navigating through the pages. If it is not, then it is a problem. right? So which means we have to understand what are the client side performance, how it is different from server side, how to measure the client side attributes, what are tools we will be using it, how to provide optimization, how to do the optimization, how to provide those recommendations. So all these things in depth, we'll be looking into it from a client side performance perspective. We will look into navigation APIs. We will look into the paint timing APIs. We will look into the developer tools. All these things combined, we will go and analyze the client side performance, and we'll learn how to provide the how to do the optimization as well. Okay. Yeah, and then from there, we'll go on to the monitoring side. Say all these things are pretty much early in the life cycle, early in the engineering, you do it, right? But when you going to do a load test, when you're going to do an endurance test, okay, first thing is, before even going to the execution phase, you have to make sure that you have a very good monitoring strategy. You should know what tools you're going to use it, what tools are available, what tools are needed, what is your application architecture, what are the various components involved, Java application server, your Tomcat, your database server, you might have a MQ, you might have a Kafka, you might have a Node.js. So what are the various components involved in your architecture? And for each component, whether it is a Windows box or Linux box, is it a Tomcat or JBoss, whether it is a Java application server or a Node.js or a Kafka or a MQ or a Oracle. So you should know each and every software, hardware, OS, right? So that you know what are tools available within your team and what tools you are going to use it. That should be part of your monitoring strategy. So we'll go and learn what things to be done as part of the monitoring strategy, and then we'll also go and learn in depth about a couple of important commercial tool and open source tools. Okay, we'll be going and setting up the AppDynamics account in the cloud. We'll be configuring it against a Java application, and then we will be will go and monitor the important metrics like your heap, your GC, your thread utilization, response time diagnostics, method level response time issues. All these things are from a monitoring, from a troubleshooting, from a diagnostic perspective. We'll go and learn how to do it using a AppDynamics kind of an APM tool. And from an open source, wherever you go, people start using nowadays open source tools. We'll also try to learn how to use one of the very famous open source monitoring tool called TickStack, Telegraph, Inflex, and Grafana or Chronograph. Okay, that as well. As part of the monitoring, we'll go and install, configure, set up, and then create dashboards using Grafana. Okay, so with this combination of tools, we'll go and run a very small load test to troubleshoot the response time problems, to identify the bottlenecks. We'll run a small test, and then using the AppDynamics, we'll go and troubleshoot